This video is going to take you through working with if statements within your Robot C code. Now, what's nice about the if statements is you can kind of give true or false if-else commands to your program, so it kind of follows a pathway. And it's really similar to how a while loop works. We already talked about how we can create those forever loops when a certain sensor gives you a value. But the thing about if statements is on their own, they do not repeat the code. So once you get to the end of the if statement, it's done. And it will essentially do it one time. So the construction of the if statement is very similar to our while loop. So we have our if statement. We have the condition, and your program will check if that is true or false, whether it is 1 equals 1 and tries to run it all the time, or if you have a certain sensor input that you want, and then it will complete a command. But what's nice about these if statements is you can kind of give the program an ultimatum. If this happens, do this, or else do this. So the if-else statement is just an expansion of the original if statement. So you can almost think about it as it's kind of like a choose your own adventure path where your program is going to reach a point where it needs to identify if something is true or false. If it is true, it's going to follow down your if path, or else it's going to follow down another path. So what's nice about these is if your pseudocode is accurate, if you're writing down exactly what you want it to do, the if-else statements almost build itself. But again, when it rolls through the whole thing, it's only going to do it once. So we have our if condition. It's going to complete that if that condition is met, or else it's going to do the other thing. So it's going to do one or the other. It's not going to do both as it rolls through that. So again, we're dealing with some nonlinear code compared to our until statements. Now, if-else statements can get very confusing if you have too many. And one issue that typically comes up is if you have multiple if-else statements, sometimes those statements will contradict each other and essentially fight. They won't actually work. So let's look at an example that looks that kind of shows that. So we have our forever loop. So notice how we have if-else statements within a while loop. So this is going to keep going on forever and ever and ever and ever and ever until our program ends. So we have one section, if you look at kind of this top half, is dealing with your bump switch, and they've named it bumper instead of bump switch. So if the bumper is equal to 1, or if your bumper is pressed, your right motor is going to start, or else it's not. Not too bad. Now if we go to the limit switch, if it's equal to 1, so if your limit switch is pressed, your right motor is going to start counterclockwise at half speed, or else it's going to stop. So we run into a problem with this statement because you're giving it contradictory information. Because if your bumper is pressed, it wants you to start the motor, but if your limit switch is not pressed, it's telling you to stop the motor. So when you do one thing or the other, it's not going to work, because if this is telling it to start the motor, this is telling it to stop the motor. So we need to be really careful, and a lot of times if you see your code stop at a certain point, it's probably because you have a contradictory if-else statement in there. But what we can also do is we can kind of embed if-else statements within if-else statements. So this is like you're on the third level of a dream in Inception. So if we have our bumper being pressed, it's going to start our motor, or else, and this is separately if our bump switch is not being pressed, then you can do your limit switch, and if none of that is happening, then you're just going to be stopped. So notice how by nesting that, by kind of changing the decisions your code has to make, we can prevent contradictions or fights. So when you write down your pseudocode with if and else statements, it almost builds it for you and shows you how to nest each of those. So we can kind of think of it the other way. If you are trying to figure out, you wake up one morning and you need to figure out if you need a coat. And we're trying to code them. So imagine children as kind of robots that don't listen to the code you actually type. But let's say for once they're actually listening. So you can say that, okay, I need to figure out when I want to wear a coat versus a jacket versus a hoodie. So you could say if it's below 40 degrees, wear a winter coat. And so your little robot child will check, is it under 40 degrees? Yep. They put on a winter coat, and that's it. Or else, so if it is not below 40 degrees, then it has a decision to make. If it's below 50, so in between 40 and 50, wear a hoodie, or else just don't wear a jacket at all. So notice how we kind of create that embedded if-else statement within the actual problem. And there are many, 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 many ways to do this. There's not one specific way. So if we look at the previous case where we have our bump switch is kind of the primary if-else statement, and if that's not being pressed, it trickles down to the limit switch or stopping the motor. If you look on the other side, we have what we call an else-if statement. And an else-if statement is essentially this portion of the code right there. It does exactly the same thing. So if you feel the else-if statement works the best for you, hey, go crazy, do it. If you like to separate your if and your else and kind of embed them together, then you can do that as well. But one thing that will help you a lot is that compile program, because your compile program will automatically tab your different sections. So if we notice all of our brackets set up over here, it will automatically format that for you. So if you find that maybe this if statement is all the way over here, you know there's a formatting issue that's not going to help when you actually start your code. So compile programs and if-else statements work really, really, really well together. So let's check out an example. Let me jump into my robot C, and I have a task that I want to do. So I want my program to loop forever. So we're going to use the while loops that we've been working with. I want to run the right motor at full speed until the ultrasonic sensor detects an object that's pretty close by, or else I want it to run at half speed counterclockwise. So let's, I'm going to break that into pseudocode. Let's do the easiest one is to loop forever. And I'm just going to take bits of my task description and I'm going to plop that in. Cool. I want it to loop forever. Let's tab over. And then I want to have this chunk right here. So it's the portion of my if statement. If we have an object really, really close. And then I'm going to do kind of that last little bit. Let's delete that. Let's bring everything back together. So we have the first one where it's if there's an object that is closer than 10 inches, it's going to do this, or else I want this to happen. Okay, so that will help us kind of build our work. So let's start with that first chunk. Let's loop this puppy forever. So I'm going to create my while loop. So I'm going to say while 1 equals 1, which is always a true statement. That's a good thing. Oops, and I got rid of that guy. Let me tab over. And I'm going to kind of open up my, my bracket so I can start doing the code within my while loop. And now this is where we get into our if statement. So I'm kind of looking for if there is an object that is equal to or less than 10 inches away, I want my right motor to run full speed clockwise. So I'm going to take this little bit right here. I'm going to paste it in, and I'm going to start working with my my if statement. So I'm going to say if, and I'm going to say my sensor value, just like we did for the while loops, if the sensor value of my sonar, which is my ultrasonic detector, is less than or equal to 10, I want my program to kind of make a choice. So let me close the parentheses right there. And we can jump into my if statement. So let's get down one level. And I want a bracket because I want code inside of my if statement to run if that condition is being met. So I'm going to say, okay, if all of this is happening, I'm going to say start my motor. And I'm going to focus on my right motor. And that is going full speed clockwise, so a positive 127. So I'm going to close my parenthesis, and I'm going to put a semicolon. That kind of designates the end of that command. and I also want to close off. That is the end of my if statement right there. So as I look at this, this looks really confusing. So if you get lost, if you say, oh man, I can't follow this junk at all, one thing that will help you a lot is to use that compile program button. Because if I use that compile program button, it will automatically format everything that I need, which is going to be really, really. So if we want, we can compile the program, and then your big ticket item is that fix formatting, which is beautiful. So notice when I click that button, everything is nice and formatted. I have my if statement that is nested within my while loop. And it's going to be a lot easier for me to see what the heck is going on. So we have the first part, which is if my sensor value is less than or equal to 10 centimeters. So if something is getting close to my ultrasonic sensor. And we want to do the other portion of that, which is our else statement. So I'm going to say, or else, and there's no conditions because it either happens or it doesn't happen. So I'm going to bracket that puppy up. And if that is not going on, I'm going to say start my motor. And I'm going to pick out my right motor. And I want it to run counterclockwise at half speed. So -63. I'm going to close my parenthesis and I'm going to toss my semicolon in there. And let's kind of put this in there so I can see my work. And then I've got a floating bracket. So let's see if everything works out. Let's fix the formatting. And everything looks good. We have everything kind of within my while loop right there. And then the if-else statement is in between. So if I were to compile and download this puppy, it's going to loop forever. When it gets to that if statement, it's going to check if there's something within 10 inches or centimeters, depending on your setting. And if that's true, it's going to start your right motor at full speed. If that's not true, it's going to have it go other direction at half speed. Now, you may run into some examples where two things might not be enough, where you have multiple values that have kind of different sections of what you want it to do. So let's say we have an example of I'm trying to control my motor with a potentiometer. So I'm almost treating it as a knob where the more I twist my potentiometer, the faster I want my motor to go. So I decide as long as we're between 0 and 500 on the potentiometer, the motor is going to be stopped. If I go in between 500 and 1,000, it's going to go half speed, and higher than that is going to be full speed. And there's a couple of different ways that we can do that. The first one is using Boolean logic. And really the only thing that we're adding in here is we have multiple if statements, but for that chunk in the middle, when it's between 500 and 1,000, I need to provide multiple values to show what that is. So my first little chunk is less than 500. We just need one value for that. My last part is over 1,000, but for that middle part, I need to say that it is greater than 500 and less than 1,000. So the way that I'm going to do that is with my Boolean operator. So if I want and, I'm going to put 2 ampersands, so that is shift 7. And if I want it to be or, so I have it kind of make a decision. It's kind of rare that we use those, but just in case, we type in this 2 vertical lines. So those are located if you hit shift and you kind of look up a couple of keys on your keyboard where the / is. So shift, and then there's that vertical line to put that in there. So if there are multiple things going on, multiple ranges, we can deal with that. But a lot of times this is actually going to waste a lot of processing power because it's going to have to check every single one of these all the time over and over and over. And the more complicated your situation is, the more processing power you're going to eat up. So if you decide to try to save on some of that power, there's a step if you want to use if-else statements to complete that, where we're just restructuring everything and saying if it's less than 500, then do this. And so if that's not true, we're going to go to the next step. If it's less than 1,000, because we already checked for the 500, so it's already between 500 and 1,000, or else everything else is not going to work. So now you've got a little bit of backup, a little bit of strategy. This is going to take a lot of practice doing. So go ahead and jump in, continue with 3.1.4, working on your while loops, your if-else statements, and your timers.